Hello everyone, we're going to start off today by looking at the answers instead of doing a separate video for this. Just wanted to have you scroll through and check your answers to the slope fields gift from yesterday. So we did 1 through 3 and 7 together. Take a look at 4, 5, and 6. Now after I show you all the answers, I have a page where the differential equations are solved. So for instance, for number 4, how I'm coming up with y equals 1/2 x plus c, I will show that afterwards. Now, if these questions show up on any AP free response portion of the test, as long as your slopes look close enough, they have the right sign, so they should look positive or they should look negative and very close to a 1/2, or if it's very far off from a 1/2, then you'll lose some points. So you don't have to always write them down, because you're going to take a look at an example we're going to do today where you don't have to write the slope out next to each individual marking. So the first two, 4 and 5, had values that involved, well, 5 had a value involved x. 4 we could have done x or y because they're 1/2 everywhere. But 6, notice where I wrote the slopes is because I had to take every y value, so all of the slopes in each row appear to be the same, where in 5 all of the slopes in the columns appear to be the same. Here's 8 and 9. Pause the video if you still need more time to look at those. Then here are all the matching. Now keep in mind for 10 through 17, the way we want to match is every differential equation at the very bottom. In order to match, we're just looking at the individual little segment, the slope of those segments, to see that they match up. For 18 to 25, if we can sketch a general curve in, we're trying to match that curve with the equations below. So those are the differences between 10 through 17 and 18 through 25. So please let me know if you have any questions on these. All right, so like I said, here's the work. We'll start with number 4, show you 4 and 5. So solving the differential equations to get the general solution. Pause the video if you need more time. There's a start of number 6 at the bottom. Just to point out, when you go to take the integral of each side, please make sure you show that step. Here's the rest of number 6. Again, pause the video if you still need more time. We did number 7 together. That one, for instance, you would want to use the differential equation solver on the calculator. Take a look at number 8. And then number 9, I'll scroll down. Now pay close attention to something like number 9. Something else we could have done for this here. I just rewrote the natural log first as log base e, or we could have said e to the natural log of the absolute value of y plus 1 is going to equal e to the x plus our third constant here. And then this just becomes absolute value of y plus 1. We'll separate this e to the x times e to the c, so this is another way. And then this will become a. So we have the absolute value of y plus 1 is going to equal a times e to the x, and then we're right back to this step. So that was another way to look at that. All right, so what we're going to take a look at next, we're going to start Chapter 7, Section 1 today. But before we do that, I want you guys to work on an AP practice problem, a free response question. Now, normally it's 15 minutes, but in class, I am going to just allow 10 minutes to maybe try to work on it. So give yourself about 10 minutes and see what you come up with. So go ahead and pause the video and work on this. If you wish to print this out, it could be a lot easier because then you can just write right on it. If not, please make sure you sketch the little coordinate plane and points that they gave you right here. But go ahead and pause the video. right, so if you need more time, just pause the video again. Let's take a look at this. Now for part A, this was worth 2 points. And those points come from what I just mentioned when we were going over the homework, the sign of each slope. So if we do have a negative slope, make sure it looks negative. If we have a positive slope, make sure it looks like a positive slope. It's just the relative steepness of the slope in the slope lines in the rows and columns. So again, as long as you're close enough. So this one is telling us whatever point we're picking, the numerator is 1 plus the y value divided by the x value. Now, if you need to write this out off to the side, by all means do it. No, so notice there's nothing at the origin, but let's start with -1, -1. So then dy over dx is going to become 1 plus a -1 over -1, and that's just going to give us 0. So right here we have 0. That should happen. We should get a 0 anytime y is -1, so that should also happen here. So here we would have 1 plus -1 over 1. Well, that's still 0. Let's go to -1, 0. So if we have dy over dx, that's just going to be 1 plus 0 over -1. So that's giving us -1 right here. Let's go up to -1, 1. So that should give us 1 plus 1 over -1. So we're looking at a -2. And then let's go over to -2, 0. That's just going to give us 1 over -2, so -1/2. Again, as long as they look close enough. Let's try this on the other side. Let's go to 1, 0. So that should just give us 1 over 1. So that should be a positive 1. Let's go to 1, 1. That should just give us a positive 2. And then going over to 2, 0, that should just give us a positive 1/2. So 2 points for part A. All right, looking at part B, we want to solve the differential equation, and this time it has an initial condition. So let's go ahead and take a look at that. So we have dy over dx is equal to 1 plus y over x. So we definitely want to separate the variables here, and we get 1 point just for doing that. So we'll have dy over the quantity 1 plus y is going to equal, this will stay 1 over x dx. So we get 1 point just for doing that. Next, we want to take the integral of both sides to make sure you show that we're taking the integral. And actually, let's just write this as 1 over 1 plus y dy is going to equal the integral of 1 over x dx. No points for writing this, but it's still important. I should say no point just for writing that. We definitely want to take the integral of both sides correctly. We'll get 2 points for doing that. So over here, we're going to get the natural log of the absolute value of 1 plus y is going to equal the natural log of the absolute value of x, and then we can just put our c over here. And this is just like number 9 from yesterday's homework. Now we could either rewrite this as log base e and then rewrite it exponentially, or you could just say e to the natural log of the absolute value of 1 plus y is going to equal e to the natural log of the absolute value of x plus c. Over here on the left, this just leaves us with the absolute value of 1 plus y. Here we could separate this by factoring e to the natural log of the absolute value of x times e to the c. E to the c turns into a. So now we have absolute value of 1 plus y. This will still cancel here, and we're left with absolute value of x. Actually, put the a in front. A times the absolute value of x. So let's see how many points we're up to here now. So we get 2 points for getting to this step. We get another point for writing the plus c. I've got 1 more point there. All right, so we'll still continue. At this point, we're going to separate this. So we'll have 1 plus y is going to equal a times the absolute value of x. And then over here, 1 plus y is going to equal the opposite of a times the absolute value of x. So now we'll use the initial condition. F of -1 is equal to 1. So using the first one here, we'll get 1 plus 1 is going to equal a times the absolute value of -1. So we just get 2 is equal to a. And notice it just says to find a solution. So if we come back over here and we solve for y, we'll get y is equal to 2 times the absolute value of x minus 1. And that's good enough. And you're going to see it's going to work out to be the same over here. If we did 1 plus 1 is equal to the opposite of a times the absolute value of negative 1, we still get 2. In this case, we're going to get a is equal to negative 2. But if we substituted that back in, we're going to get y is equal to the opposite of a. So guess what? That turns back into a positive 2. And we get the same solution here. So that's why I'm saying most of the time we can just go based off of this. All right, so we get 1 point for using the initial condition. And we get 1 more point for answering this. Then we also need to state the domain. So for us to have an initial condition of f of negative 1 is equal to 1, so this is working when all of our x values are negative. And this could be helpful if we could just sketch the graph of this. If we were to graph y equals absolute value of 2x minus 1, here's our y-intercept, and we're going up 2 over 1 this way, and then the same off to the side here. So if we were to sketch this, we're looking for our initial condition, so this puts us on this side of the absolute value v. So this would be when all x is less than 0, so that would be our domain. Again, it has to meet the initial condition. And that would be another point. All right, so like I said, today we're starting section 7.1. And we're going to get involved with applications of integrals, and there's lots of them, especially what they like to put on the AP exam. So for today, we're going to apply and use integrals to solve particle motion problems, and we've done that before. That is to compute displacement and total distance traveled. Now I'm actually going to have you guys go back. If you could pause the video here in a little bit. I gave you guys those AP exam flashcards. I had all the sheets scanned in for you to look at. If you go to the very last section, that's entitled the integrals and antiderivative topics. And then go to items 36, which talks about displacement. 37 talks about total distance. And then eventually we're going to get into 41, and it might be related to what we're going to do today. So item 41 as well. So I'm going to go over those in a little bit as we go through our problems, but just have those flashcards handwritten out handy for you. All right, so what we're going to talk about is something that we talked about while we were looking at area versus taking an integral. An integral means just a net change in area, but it can also mean anything over time. So we're going to take a look at page 371, number 4. So with these exercises, we're asked to do two things. We want to determine when the particle is moving to the right, to the left, and stopped. And then we want to find the particle's displacement for the given time interval. So right here, we're given the velocity in this time interval. So like I just mentioned, part A, when is a particle moving to the right? And we know a particle is moving to the right when velocity is positive. We know a particle is moving to the left when our velocity is negative. and stopped when velocity is equal to 0. Even if it's for a split second, it's still stopped if it happens to be changing directions. All right, so let's go ahead and set our velocity equal to 0. And we'll solve this by factoring. Factor out a 6 first. And this will factor into 6t minus 2, t minus 1. So when t is equal to 1 or t is equal to 2, that's when our particle is stopped. Moving to the right and to the left, we have to make a velocity timeline here. So we'll put our 1 and our 2 in just a different scenario, but we've done this plenty of times before. We just need to figure out when velocity is positive or negative. So to the left of 1, I'm just going to look at this factored form right here. And we know we should start at 0, so we don't need to go below 0 here. So let's say we tested a 1/2. So going back here, I have a positive 6. This will be negative, this will be negative, so that should be positive. Between 1 and 2, let's say we test a 1.5. We'll have a positive, a negative, and a positive, so this will give us a negative, and then greater than 2, we're at positive. So moving right, I just like to use inequalities here. We'll start to say from 0, because it starts at 0, and then to 1. Don't include the 1 though. Oh, and I went beyond the 2. Our time interval was just from 0 to 2, so we didn't need that. And then moving to the left would just be in between 1 and 2. Here's another way to say that we would include 0 is to figure out v of 0, which would just be 12. So that's still positive. All right, so for part B, we want displacement. So if you recall, displacement is the change in position from one time, we'll say t equals a, to another time t equals b. So we've seen this before. Displacement is just s of b minus s of a. Written as an integral, though, this is what that item 36 was on that handout I gave you. So it's also equal to the integral, the antiderivative, of a to b of v of t dt. And remember, this could be positive, negative, or 0. When we get a negative displacement, it just means we're to the left of where we started. A displacement of 0 means we ended up right where we started. A displacement that's positive means we're to the right of where we started. And hopefully this makes sense because the antiderivative of velocity is position evaluated at t equals b to t equals a then. So let's go ahead and find this. So here, our displacement, because again, we're just looking at the net change. So we would go integral from 0 to 2 of 6t squared minus 18t plus 12 dt. If you want to pause the video to give this a try. All right, so we're simply taking the antiderivative of each term. So we'll get a 6t cubed over 3, so we just get a 2t cubed. This becomes minus 18t squared over 2, so minus a 9t squared. And then plus 12t. We don't need a plus c because we're going from a definite integral here. So then we'll get, substituting in the 2 first, we'll get 2 times 2 cubed minus 9 times 2 squared plus 12 times 2. Technically minus everything will turn into a 0 here. So it'll give us 8 times 2. We have 16 minus 36 is negative 20 plus 24 gives us 4 meters. Displacement of 4 meters, which means the particle is ending up 4 meters to the right of where it started. So that's still a net change. It's a difference 4 meters to the right then. That's how we're interpreting this. There's actually a part C here to find the total distance traveled by the particle. So again, we know this is just like total area. So we could do this graphically. I'll come back to this. So the total distance traveled using integrals. Let's go back. We know when it changed direction. So we know our particle changed direction at 1, and then it stopped at 2. So we're good with that. We don't have to worry about that part. But let's go ahead. We can graph the velocity function. And we could kind of graph it right over this because we know our velocity function was a quadratic, so we know our parabola is above the x-axis between 0 and 1. So we know it crosses here, and it's coming up, and it's about to cross here, and it would continue up this way if the time didn't stop there. So we know that this part of the area would be shaded above, and then this part would be shaded below. So we could write this now as total distance traveled. Make sure you label everything you're trying to find. So this would be the integral. We have to do 2 separate integrals. We would first go from 0 to 1 of 6t squared minus 18t plus 12 dt. Then we could subtract the other integral from 1 to 2 of 6t squared minus 18t plus 12 dt. Now on any assignment, you would still have to do this by hand. But just to show you, this first part would come out to a 5, minus the second part would come out to a -1, and we end up getting 6 meters total as a total distance. Now how we would get the 4 is if we went straight from the 0 to 2, it would be saying 5 plus a -1, and that's giving us the 4. So let's go back to the graph. So I want you to go ahead on your calculator, graph y equals 6, make it an x though, 6x squared minus 18x plus 12. I'll erase that there, let's make it an x. And adjust your window settings just as I have here, so go to menu 4.1. And once you have that graphed, we're going to go to menu 6.7. Pause the video if you still need to enter the window settings. So menu 6 takes us to analyze graphs. 7, at least on my calculator, is the integral. And then once you select that, just go straight as your lower bound from 0 and then go to 2. So that's what your window should look like. So it's giving us the area that's above the x-axis between 0 to 1 registers as a 5. And then from 1 to 2, it's below, so there's a -1. So if we added that together, we would get the 4 for the displacement, and that's the same as just going straight from 0 to 2. But if we added them or subtracted the area below here, took the absolute value and added them together, we're getting the 6. So again, the difference between finding the total distance traveled, that's the same thing as finding the total area, versus the net change in area, which would be the displacement, the net change in position. And that's what section 7.1 looks at. So I'll assign the problems to this on Monday. But right now, Your assignment over the weekend, which will be due Monday, is a Chapter 6 graded assignment. And then these were just for practice. So on page 180, do AP problems 14 and 15. Please let me know if you have any questions.